Pay careful attention to the technique I'm going to be showing you for absolute value because it is different than what you read about in the textbook. When dealing with absolute value equations or inequalities, our focus is going to be on the stuff inside of the absolute value bars. Our technique is going to go like this. We need to take the stuff that's inside the absolute value bars, replace the bars with parentheses, and write that down twice. One time, we're going to work this equation with the positive on the 9 minus 4x, and one time we're going to work the equation with a negative. So that basically is my technique for solving absolute value equations and inequalities. One time with the positive, one time with a negative. You'll notice that commonly you come out with two separate answers. Now in attacking this, notice over here on the left, the 9 minus 4x that's in parentheses really doesn't need to be in parentheses at all. When we finish solving, we will subtract the 9 from both sides, and divide by negative 4. Over on the right, we're going to distribute the minus sign, add 9 to both sides, and divide by 4. So again, there are two answers to this. I'm thinking that in the my math lab, when you go typing answers, you're going to have the braces already there, and you need to type simply the two answers separated by a comma. Do not put brackets or parentheses on there because this is not an interval. It's just two numbers. So the nice thing about my technique is that when we're solving inequalities, we do exactly the same thing. Here is the 4x minus 6 less than 10. All I've done is write this down without the bars. Now, where the bars were, I'm going to use parentheses and put a minus on the front. So same technique as we just did. And then I'm going to solve each of those. So in the first one, if I add 6 and divide by 4, and the second one, if I distribute the minus sign just like we did in the beginning, subtract 6, and divide by negative 4. So remember from the previous section, a couple of sections ago, when we divide by negative, we reverse the direction of the inequality. Now here is my line. I've got a mark at 4 and at negative 1. So here's the negative 1 on the left, and here's the 4 on the right. And here it says I need to shade to the left of 4. And here it says I need to shade to the right of negative 1. So there would be the shading. since the symbols do not have the line under it, there would be open circles at the -1 and the 4. So now here is my answer in interval notation. -1, comma 4, parentheses on both. So hopefully you're catching on by now, so I will go through this a little quicker. Again, notice the symbol is different than the previous problem. However, my technique is the same. I have a 4x minus 6 greater than 10. I have a 4x minus 6 in parentheses with a negative on the front greater than 10. Again, I'll give you a caution. If you're trying to read your book, do not blend my technique with their technique. You either do it the way I'm showing you or do it the way your textbook shows you, one or the other. Don't blend them together. And again, we'll go through the solving process. We add 6. Divide by 4. Distribute the minus sign. Subtract 6. And divide by -4, which again changes the direction. Here are the -1 and the 4. And just like before, we're looking at this and saying, okay, where do we shade? This says shade to the right of the 4. This says shade to the left of the -1. Same interpretation on the symbols. If there's no line under it, there's an open circle here. Now, the interval notation gets a little trickier. The shading that we have here has a negative infinity on the left, a -1 on the right. Infinity always gets parentheses. This -1, because of the open circle, will be a parentheses also. This shading has a 4 on the right, and 4 on the left, sorry, infinity on the right, with parentheses on both of them. Now there's a magical symbol that says when you have two separate things like this, you join them together, and that symbol looks like a capital U. It's called set union. It'll appear in the My Math Lab bar at the bottom of the problem. So I hate to sound like a broken record, but if you're using my technique that I've been showing you all along, you should know by now. We're going to write 5 minus 8x plus 6 greater than or equal to 14. We're going to write 5 minus 8x with parentheses around it and a minus on the front of it, plus 6 greater than or equal to 14. And then we're going to solve each one of those. On the left, we've got a 5 plus 6, which is an 11. If we subtract 11 from both sides, we get -8x and 3. If we divide by -8, we get x. We get -3/8, and of course, since we divided by a negative, we change the direction. Here, we're going to distribute the minus sign and have -5 plus 8x. -5 plus 6 is 1. When we subtract 1, we get 8x and 13. We divide by 8. And we get x and 13/8. No one ever said the answers were going to all come out to be nice, neat numbers. However, just like we've been doing, here's a line, here's a -3/8, here's a 13/8. We're shading to the left of the -3/8. We're shading to the right of the 13/8. There is a solid dot at the -3/8 and a solid dot at the 13/8. In interval notation, this would be -infinity, comma, -3/8, bracket, parentheses. This would be 13/8, comma, infinity, bracket, parentheses. Set union in between. Now sometimes we can apply a little bit of logic ahead of time and save ourselves some trouble. For example, here's an absolute value, and this says it's coming out to be negative. Well, the absolute value bars, of course, would simply make this positive. So the only way that this could be 0 is if one solution came out 0. In other words, we can take 7x plus 28 equals 0 and solve that and not have to do the second one. That's 7x equals -28, or x equals -28 divided by 7. And so this one has only one solution. Now, using similar reasoning to the previous problem, notice here we have a -2. The only way for 6x minus 9 within absolute value bars to come out is to come out positive. So the question is, well, what numbers can you put here so that this positive number is greater than -2? And the answer is you can put anything you want there, because when you do the absolute value of whatever you come out with, it will always be positive, which means it will always be greater than -2. So without doing a single bit of algebra, I can say the answer to this is -infinity to positive infinity, all real numbers. And in a similar fashion, this question is asking us, okay, what positive number is smaller than -5? And the answer to that is there's no such thing. Now both of these are correct way of saying, and one other one, that there is no answer.